All right, AGS1 people, we're back today with 2.4, getting down to business. Now, this lesson is not necessarily anything new, but it's just kind of combining some skills that we've been working on with like linear and exponential functions, or arithmetic and geometric, if you want to think of it that way. So I'm going to do two examples for you guys about two different businesses. The first business is Calculama. They start with $5 million in 2010, and then they gain $0.5 million per year. So first thing I'm going to do is start with a little table of how much money Calculama is getting. So please notice here my years, 0, 1, 2, 3, 4. These are the years after 2010. So right here, this would represent 2011, and then this would be 2012, etc. They start with 5 million, so I'm just going to put a 5 right here rather than writing 5 million because, whoops, gosh darn it, I did not mean to erase that. The money is in millions. So 5 million they start with, and then they go up by 0.5. So the next year they would get 5.5 million, then 6 million, then 6.5, then 7 million, and so on. Eventually, if you get n, well, we're going to get to that with the explicit equation in a second. So first, let's build up a graph. At year 0, so notice I have years since 2010 on my x-axis and millions of dollars on my y-axis. They start out with 5 mil. Then after year 1, they go up to 5.5. Then they go up to 0.5 again at year 2. And then 0.5 again at year 3. So that's 6.5. And then after year 4, they would hit there. So, let's see if this was supposed to make a straight line. Did I miss one? I put it in the wrong spot. You know, we do the old math trick. We'll just make those dots bigger. There we go. Now they're all on the line. So please notice that this is an arithmetic sequence, which means that we get a linear function out of it. Now, let's take all this and write an explicit equation for it. The explicit equation would be like the common difference times n plus your year 0 value. So it's going up by 0.5 every year, and then year 0 was 5. So our explicit function, let's change that 0.5 to a 1/2. In general, fractions are kind of going to be more your friend down the road than decimals. Keep those decimals in science class or for statistics. So that's 1/2 n plus 5. Now, using our equation, how much income will they make in 2020? Now, we don't necessarily have to expand our table out to 2020. We can just use our model for it. So, 2020 is 10 years after 2010, so they're asking us to find f of 10. So you do 1/2 times 10 plus 5. Half of 10 is 5, so you get 5 plus 5, which equals $10 million. Or I guess we could say 10, 1, 2, 3, 1, 2, 3. That's how much money they're making in 2020. Must be nice. The second example, Computer Fest. It's a terrible company name. Computer Fest sounds like a festival. It starts with 2 million, so they start with less money than the other company, and they increase by 15% every year. So let's fill out a table for them with the years on the left. They didn't say in what year. Maybe they're starting in 2010 as well. That would make sense with the context of the problem because I think you have to compare these two companies. But they're going up by 15%. So in year 0, they have 2 mil. Then to get up to the next year, you could do 0.15 times 2 and then add that on to 2. Or you can just do 2 times 1.15. because it's like they're keeping 100% of their money but getting 15% more. So this is 2.3. If you take each previous year and multiply it by 1.15, you should get the next year. So this is 2.65, about. I'm going to round my decimals appropriately. And then the next year would be 3.04, and then times 1.15 again, 3.5, about. And this could continue. So, notice my graph. I have money on the left in millions and time in years on the x-axis. So, at year 0, they're starting at 2 mil. Then, after the first year, they go up to 2.3. Let's see, 1, 2, 3, 4. This would be halfway. That's 2.25, like right about here. Trying to be as accurate as possible so you guys can see your relationship here. Year 2, they get to 2.65. So here's 2.5. Let's just go a little bit above that. Then they go, in year 3, they go up to 3.04. And then 3.5, which will be 1, 2, 3, 2 blocks up. So now, it might be a little bit hard to see here, but there actually is a curve to this. This is not linear. It kind of looks straight, but if we were to keep going further and further out, you would see that this is kind of getting this nice curve to it. So I'm going to exaggerate the curve. And here, let's get rid. Oh, son of a gun. Let's go. Just to show that it is curved. And we'll make that one right around here. So this is geometric because it's getting multiplied by 1.15 every single time. But in terms of functions, this is going to be an exponential. Exponential function. The explicit equation. Well, you start with day 0, excuse me. So day 0 from the graph is that they start with 2 mil. So that's 2 million. And then the common ratio is this guy. It's the 1.15. It's going up by 15% every year. So this is times 1.15 to the power of n. How much money will they make in 2020? Well, that's 10 years past 2010. So they screwed up the wording of this. I think they start with $2 million in 2010. So these are years since 2010. Okay, so we're going to put a 10 in here because that's 10 years past 2010. 2 times 1.15 to the power of 10. I'm going to grab my trusty calculator for that one because I definitely do not know 1.15 to the power of 10 offhand. Oops. 8.09. About. And that's million, mind you. So, let's kind of go back to what was happening with the first company in 2010. So the first company in 2010 was linear, and they were growing arithmetically, and they were getting 10 million in 2010. ComputerFest is getting 8 million in 2010. So I think in the Go Formative, they kind of start asking some questions about, like, you know, will Calcurama always have more money than ComputerFest? Like, ComputerFest definitely has way less money, like, here in their table than in the table here. They start at 5, and they're up to 7 by year 4, and here they start at 2, and they're up to 3.5. So the one question comes to mind, is ComputerFest ever going to catch up with Calcurama? Is one of them growing faster than the other? I'm going to let you guys think about that. I would recommend maybe extending these tables if you're not sure. That could be a starting point. Or if you want to get fancy, you could graph both of them at the same time, or you could just check, like, you know, after 100 years, are they going to have the same amount of money, or who will have more? I'll let you guys play with that. It's super fun. All right, guys.